Hello, we'll be talking about zip challenge from Google CTF2023 in crypto category. The challenge description is someone wrote their own explanation of PKZip compatible extract encryption to produce an encrypted zip file. The PKZip compatible cipher is old and known to be weak, but did the order leak sufficient information for you to decrypt the flag? Introduction. The challenge provides two files, a protected zip file named hard.zip as well as a Python script that is presumably used to generate it named hard.py. A review of Beham and Kosher, a known plain text attack on the PK stream cipher, could be quite helpful before attempting this challenge. Reviewing the hard.py shows that the pure Python implementation of a quite minimal zip archiver. The script takes three command line arguments: a password of pkzip encryption, a file containing the flag, and an encrypted zip file to create. The script ensures the flag begins with CTF open curly brace and ends with a closed curly brace. Comparing the encryption algorithm to PKWare specification, the implementation appears correct. In addition to the encrypting flag and placing it in the archive, the script also generates 4 random bytes as junk.dat and encrypts that file and places it in the archive as well. A review of the specification also states that the PKWare encryption incorporates 12-byte encrypted nonce, and by convention, the last byte of the nonce is most significant of the CRC32 value of the plaintext. Hard.py follow this convention. Additional review of the hard.py shows that it encodes strings using a character set of UTF-8-6. What is UTF-8-6? This means that the encode using UTF-8 implement a quite unnecessary Unicode byte order marker. In UTF-8, the byte order marker is encoded as EFBBBF. Depending on the setting in the save as dialog, it is possible to accidentally generate a file in this format using the Windows Notepad, and the invisible bomb can be quite frustrating when passing the resulting file to other tools. But here the insertion of EFBBBF into the flag just provides 3 extra bytes of non-plain text. Nothing is wrong with the random number generation, including for gen.dat. So some brute force of CRC value in order to determine the plain text of zunk.dat. Even on a single core, this can be done in a minute or two. Given the CRC byte incorporated in the nonce and the bomb inserted in flag.text, now we know 9 plain text bytes of flag, 8 of which are contiguous, and given the CRC byte and brute force plain text bytes, we have 5 plain text bytes of junk.dat, as 5 of which are contiguous. Now we need to find and implement the attack of Beham Kosher. bkcrypt is an excellent tool and in reviewing the documentation, it takes a minimum of 8 contiguous bytes of known plain text to generate possible keys, and an additional 4 bytes of known plain text to eliminate incorrect keys and narrow down the correct keys. Do we have this? Yes, but only split across 2 files that happen to be encrypted using the same password. Out of the box, bkcrypt does not account for the possibility, so a quick patch is in order to add some code to generated keys based on known plain text from the flag.txt. but the filter on those that do not correctly decrypt junk.dat. A very quick patch is given in bkcrack 1.5.0.patch. It removes the check of the 12 plain text bytes and expects files in the current directory for second plain text. With byte with 5-byte plain text recovered from junk.dat and second ciphertext within 16 bytes consisting of 12 byte encrypted nonce including CRC byte and 4-byte encrypted plaintext. The patched bkcrypt then uses each candidate key to decrypt second ciphertext and compares the results to second plaintext. All keys except that one that correctly decrypts the plaintext are filtered out. The full automated solution is given in the hard database. The script first recovers the known plaintext bytes by for flag.txt and passing to bkcrypt using the -x command option. The script then copies the 16 byte ciphertext from junk.dat to the file second underscore ciphertext and calls crackcrc to guess the 4-byte plain text. After pending Prepending the plain text with the most significant byte of the CRC, crackcrc saves it to the second file second plain text. You may download bkcrypt 1.5.0 and patch it using this path to bkcrypt 1.5. Next, the patched bkcrypt execute using 8 core. bkcrypt discovers the key is about 1 hour and 15 minutes. Key in about 16 records in, 16 records out, 16 bytes copied. Wait, wanted CRC base, starting value, ending value, plain text found, bkcrypt 0.1.0, 1.5.0 attack on. This Z values are index 6, keys are these 91.9, and these will be the keys. Given the keys, the change -change keys bkcrypt option can be used to re-encrypt the file using a different password, and then the file can be decrypted to recover and submit the flag value from flag.txt. Bomb removed, of course. Of course.